Hello friends, today let's see what happens when we eat food. So when we eat food, your blood sugar will be increased. This is controlled by the hormone insulin. How does insulin control your blood sugar? Insulin stimulates your glycolysis. What is glycolysis? Glyco means sweet. Lysis means splitting. So the sugar or sweet is splitted to form pyruvate. Okay. Now let's move on to the cycle per se. So glucose is converted to glucose 6-phosphate, which is converted to fructose 6-phosphate, which in turn is converted to fructose 1,6-bisphosphate, which gives two products, glyceraldehyde 3-phosphate dihydroxyacetone phosphate. Now this glucose is a 6-carbon compound, glyceraldehyde 3-phosphate is a 3-carbon compound, this is also a 3-carbon. So these two are interchangeable. DHAP can be converted to glyceraldehyde 3-phosphate, and glyceraldehyde 3-phosphate can also be converted to dihydroxyacetone phosphate. So the end result will be 2 molecules of glyceraldehyde 3-phosphate. Now this is converted to 1,3-bisphosphoglycerate, which is converted to 3-phosphoglycerate, which is converted to 2-phosphoglycerate, 2-phosphoenol pyruvate, and finally pyruvate. Okay. So what are the enzymes acting? So glucose to glucose 6-phosphate, addition of a phosphate group. So the enzyme should be kinase, hexokinase. Now glucose 6-phosphate to fructose 6-phosphate, isomerization takes place. So the enzyme is isomerase. Next, fructose 6-phosphate to fructose 1,6-bisphosphate, another phosphate group is added. So the enzyme is again kinase, Phosphofructokinase. Okay. So fructose 1,6-bisphosphate is converted to glyceraldehyde 3-phosphate and dihydroxyacetone phosphate by aldolase. Now glyceraldehyde 3-phosphate is converted to 2 molecules of glyceraldehyde 3-phosphate is converted to 1,3-bisphosphoglycerate by the enzyme dehydrogenase. Glyceraldehyde 3-phosphate dehydrogenase. Now this 1,3-bisphosphoglycerate is converted to 3-phosphoglycerate. Here there is removal of one phosphate group. Again the enzyme is kinase. 1,3-bisphosphoglycerate kinase. Now 3-phosphoglycerate is converted to 2-phosphoglycerate. The enzyme is mutase. Phosphoglyceromutase. 2-phosphoglycerate is converted to phosphoenol pyruvate by enolase. Phosphoenol pyruvate to pyruvate by pyruvate kinase. Okay. So this is the overall cycle and the enzymes involved. Now let's move on to energetics. So wherever kinases are involved, there is either utilization of ATP or regeneration of ATP. Now let's see the first enzyme, hexokinase, where glucose is converted to glucose 6-phosphate. The enzyme is hexokinase. So there is an addition of a phosphate group. So what happens? ATP is converted to ADP. Similarly, the next kinase, that is phosphofructokinase. Fructose 6-phosphate to fructose 1,6-bisphosphate. The enzyme is phosphofructokinase. There is addition of another phosphate group, so ATP is converted to ADP. Now what about the other two kinases, namely 1,3-bisphosphoglycerate kinase, 1,3-bisphosphoglycerate kinase, which converts 1,3-bisphosphoglycerate to 3-phosphoglycerate. Here there is a removal of a phosphate group, so what happens? ADP plus inorganic phosphate will give your ATP. There is regeneration of ATP. The next kinase is your pyruvate kinase. Phosphoenol pyruvate is converted to pyruvate. The enzyme is pyruvate kinase. So here also there is regeneration of ATP. Okay. And there is also regeneration of NADH. Glyceraldehyde 3-phosphate is converted to 1,3-bisphosphoglycerate. So the enzyme is glyceraldehyde 3-phosphate dehydrogenase. So NAD is converted to NADH. Okay, this is your overall pathway, the enzymes involved and the energetics of glycolysis. Now let's see the easy and fun way to remember your compounds, the reaction and the products. Okay, so I'll tell you a simple mnemonic. For the pathway, the mnemonic is George gave Felix fresh grapes and dates to bake plum cake, pancake and peanut pizza. So this is your mnemonic. Here G represents your glucose. Next G, glucose 6-phosphate. This F, fructose 6-phosphate. Fructose 1,6-bisphosphate. G for glyceraldehyde 3-phosphate. D for dihydroxyacetone phosphate. B for bisphosphoglycerate. P for phospho 3-phosphoglycerate. Another P for 2-phosphoglycerate. Next P for phosphoenol pyruvate. So PE you can remember. Phosphoenol pyruvate. And again next P for pyruvate. Okay. So George gave Felix fresh grapes and dates to bake plum cake, pancake and peanut pizza. Now let's see the mnemonic to remember your enzymes. Okay. Happy Peppa Pig also gulped baked peanut pizza. So here H stands for hexokinase. Phosphofructoisomerase. Next phosphofructokinase. A for aldolase. G for glyceraldehyde 3-phosphate dehydrogenase. This B stands for bisphosphoglycerate kinase. Phosphoglyceromutase. This P stands for phosphoglyceromutase. This E stands for enolase. And this P stands for pyruvate kinase. So Happy Peppa Pig also gulped baked peanut pizza. This is your mnemonic to remember the enzymes. This mnemonic can be used during your revision, last minute revision. Okay. Now let's discuss the energetics of glycolysis. So the first step, glucose to glucose 6-phosphate, the enzyme is hexokinase, ATP is utilized. And the next step is fructose 6-phosphate to fructose 1,6-bisphosphate, where there is utilization of ATP. So you can write as minus 2 ATPs. The next step, glyceraldehyde 3-phosphate to 1,3-bisphosphoglycerate, 2 molecules. So here 2 NADH is produced. This NADH is going to enter into your electron transport chain to generate 2.5 ATPs per molecules of NADH. So 2 NADH will form 2 into 2.5, which is equal to 5 ATPs. Okay. So initially we had minus 2 ATP plus 5 ATP. The other two steps are 1,3-bisphosphoglycerate to 3-phosphoglycerate. The enzyme is again kinase. Here there is regeneration of ATP. 2 molecules, so 2 ATPs. Again phosphoenol pyruvate to pyruvate. We have regeneration of 2 ATPs. So total 4 ATPs. So plus 4 ATP. So total it now. Total 7 ATPs. 7 ATPs are produced per cycle of glycolysis in oxygen, now what happens, or aerobic glycolysis. Okay, 7 ATPs in aerobic glycolysis. Now what happens in anaerobic glycolysis? The end product is not pyruvate, but pyruvate is converted to lactate. So the NADH produced initially in the dehydrogenase step is utilized here. Okay, so that gets cancelled. So now what is the total number of ATPs? Minus 2 ATP, that is 2 ATPs are utilized, plus 4 ATPs which are produced. So your total will be 2 ATPs in anaerobic or oxygen deficient condition. 7 ATPs in aerobic glycolysis. Okay, now let's see the significance of glycolysis. So this pathway takes place in almost all the cells. For RBCs, this is the only source. So during your exercise, this will be anaerobic glycolysis will be the source of energy. Okay. So this pathway also provides carbon atoms for the synthesis of glycerol part of fat and some amino acids. Okay. So these are the significances. Now to summarize, let's see the mnemonic. George gave Felix fresh grapes and dates to bake plum cake, pancake and peanut pizza. So glucose 6-phosphate, fructose 6-phosphate, fructose 1,6-bisphosphate, glyceraldehyde 3-phosphate, dihydroxyacetone phosphate, 1,3-bisphosphoglycerate, 3-phosphoglycerate, 2-phosphoglycerate, phosphoenol pyruvate and pyruvate. Now the mnemonic to remember your enzymes. Happy, Peppa Pig, also gulped, baked, peanut pizza. So hexokinase, phosphofructoisomerase, phosphofructokinase, aldolase, glyceraldehyde 3-phosphate dehydrogenase, 1,3-bisphosphoglycerate kinase, phosphoglyceromutase, enolase and pyruvate kinase. So the energetics in aerobic condition 7 ATPs, anaerobic condition 2 ATPs. Significance, only pathway taking place in all cells, only source of energy for RBCs, and in case of exercise this will be your major source of energy for muscles. Okay, so this is the easiest and fun method to remember your glycolysis, all the reactions and your products in a simple way. Thank you.